Now, the good news for you is that I'm using only simple expressions here. I'm not using any repeated factors. I'm not using anything that cannot be reduced or repeated cannot be reduced. All of our factors are going to be linear, like ax plus b type factors. That makes it a lot easier. All right, let's look at this one. If we're going to take this and split it up, then we're going to have a over 3x minus 1 plus b over x plus 4. And when we find a and b, we have finished the algebra, and we're ready for the calculus. Now, multiplying by this, I have a times that plus b times that equals that. And equating coefficients, I have a and 3b equals 7. I have 1a plus 3b equals 7. And for my constants, I have 4a minus 1b equals 2. 4a minus 1b equals 2. Once again, I have 4a minus 1b equals 2. Now, I can let x equal negative 4 or x equal positive 1/3. I'm looking for what makes these 0. And if x equals negative 4, this becomes 0. And if x is negative 4, that is negative 13b. And if x is negative 4, this whole thing is negative 26, which tells me that b is 2. And now if b is 2, I can plug it in here, and that becomes a 6, and I get a is 1. Or you could plug it in here. If b is 2, that when I pull it over, that becomes 4, and a is 1. I've done the algebra. I've rewritten this as 1 over 3x minus 1 plus 2 over x plus 4. And if that's u, that's 1/3 of a du. And if that's u, that's 2 dus. Should probably actually have absolute values there, plus a constant. So finding a and b is the algebra, and then we use calculus to go further. Let's do another one. I'm going to break this down into a over x plus b over x minus 2 and say it equals this. And when I multiply both sides by that equation, I get a times x minus 2, because that canceled out, plus b times x, because that canceled out, equals x plus 8, because both of those canceled out. Equating coefficients, I have 1a plus 1b equals 1. 1a plus 1b equals 1. Those are the coefficients of x. My constants are negative 2a, 0 equals 8. Well, this one's easy. A is 4. And if a is 4, then b is negative 3. So I have 4 over x plus negative 3 over x minus 2, and that's the algebra. If that's u, that's 4 du, so that is 4 ln absolute value of x. If that is u, that is negative 3 du, so that's minus 3 ln absolute value of x minus 2, plus a constant. Let's do another. Algebraically, this is going to be a over 2x plus 1 plus b over x plus 2. And doing the cross multiplying, I have a times x plus 2 plus b times 2x plus 1 equals negative 1x minus 11. Equating coefficients, I have a for x's and 2a for my constant. Equating coefficients, I have 2b for my x's and 1b for my constant. And over here, I know that the x's are going to equal negative 1, and my constant is going to equal negative 11. Once again, I have 1a and 2a. Those are the x's. Those are the constants. I have 2b and 1b. Those are the x's. Those are the constants, and it's going to equal that. Now, if I let x equal negative 2, that becomes 0. If x equals negative 2, that becomes negative 5b. No, negative 3b. And if x is negative 2, that is negative 9. So b is 3. And right here, if b is 3, adding a negative 3, I have a is negative 7. We've done the algebra. Let's look at the calculus. If that's u, that's negative 7/2 of a du. If that's u, that's 3 du's. Plus a constant. Y'all remember my waitress? Plus a constant. Okay, so this one's a bit more complicated because we have the irreducible factor here. I'm not testing you on that, and I didn't put that, I don't think I am, I didn't put that in the homework, but let's go ahead and work it out. Because I can't reduce this, and that starts with an x squared, I'm going to have ax plus b over x squared plus 1 plus c over x minus 2. And when we do the cross multiplying here, I'm going to have ax squared, do your FOIL, minus 2ax plus bx minus 2b. And here, I'll tell you what, let's do that differently. Let's do that differently. Probably simpler this way. Let's say ax times x minus 2 plus b times x minus 2 plus c times x squared plus 1, and that's going to equal 1x squared minus 7x minus 5. Can't make that 0. But if I let x be 2, then those are both zeros. And I have 5c. If x is 2, that says 4 minus 14, which is negative 10, minus 5, which is negative 15. And that gives me that c is negative 3. C is negative 3. And I have ax squared. Let's look at the x squareds. I have ax squareds minus 3x squareds, and that equals 1x squared. So that tells me that a is 1. And if a is 1, that's negative 2x. And that's bx. And there are no x's there. And that equals negative 5x. That tells me that b has to be negative 3. All right, so this becomes, a is 1, that becomes x over x squared plus 1. B is negative 3, that's negative 3 over x squared plus 1. And that's negative 3 over x minus 2. Now, if that's u, that's half a du. And that doesn't fit a u du, but that's 3 arctan. Remember your arctan function. You don't need absolute values there because that's always going to be positive. And if that's u, that's negative 3 dus plus a constant. So that's how you do it when you have an irreducible factor. Let's look at this one. If I wanted to split this up, that's a repeated factor. I'd have a over x plus 3 plus b over x plus 3 squared. It's like the 12th. I can split it down into halves and thirds and fourths, but fourths are just halves squared. So we have to account for that possibility. Plus c over x minus 2 equals, and then we go through the algebra to find a, b, and c, like we did on the last one. Let's try another one. This one's fairly simple. This is going to be a over 3x minus 1 plus b over x plus 4. And when I do my cross multiplying, I'm going to have a times x plus 4 plus b times 3x minus 1 equals 7x plus 2. Now let's equate coefficients. I'm going to have ax's, and I'm going to have a for my x's and 4a for my constant. I'm going to go ahead and do it that way. I'm going to have 1a for my x's and 4a for my constants. I'm going to have 3b for my x's and negative 1b for my constants, x's and constants. And that's going to equal 7 for my x's and 2 for my constants. Now, if I let x be 1/3, that becomes 0. Or if I let x be negative 4, that becomes 0. And most of my students don't like fractions. So x is negative 4. And that becomes 0. And that's negative 12 minus 1 is negative 13b. And if x is negative 4, that's negative 28 plus 2 is negative 26. So b is 2. And if b is 2, then a is 1. We've done the algebra. Let's do the calculus. If that's u, that's 1/3 of a du. If that's u, that's 2 dus. Plus a constant. Now, I didn't include this one on the test. I usually do, but I just didn't this year. This says to write out the partial fraction system of equations. Don't solve it, write it out. So for this one, which is irreducible, I would have ax plus b. This is repeated. I would have c over x minus 4 plus d over x minus 4 squared. Remember, if we had some number of 18ths, I could break it down into thirds, sixes, or ninths, but ninths are just 3 squareds, equals 7x. And then multiplying everything by this, we'd expand it out and figure out what A, B, C, and D are. I didn't ask you to do that. That's how you do it. Good luck, and thank you to the student who asked for help on this. Be sure and let me know if you need anything else covered. I don't know for sure our exam dates, but I know they're next week. So good luck. Thanks.